Good morning, everyone. My name is David Ken, and today I'm going to be doing my project for my internship on Investigate IPv6 Transition Mechanism utilizing Windows 7, Fedora 19, VIATA, BIOS operating system. My faculty advisor is Dr. Yan Bai. My supervisor is Simon Do. All right, so for the agenda today, I'm going to be covering the introduction, the problem statement, what is IPv6, the operating systems, the tasks that I had to do, additional projects that I worked on, the learning outcomes, future plans, and conclusion. So, quick introduction. I'm a senior ITS student here at the University of Washington-Tacoma. My interest is in networking and security. My position is, I would like to say, information technology specialist in network intern, located at Dugan 110 Computer Lab. You can find me there. My primary project again is Investigate IPv6 Transition Mechanism. My secondary project is building desktop computers. Alright, so with the problem, the problem we're facing right now is that according to the Internet Assigned Number Authority, the central pool of available IP addresses is completely empty as of February 2011. Alright, there are no more IPv4 addresses to allocate to any organization. That includes UWT. Alright, IPv4 is getting more difficult to acquire. But IPv6 could be the solution to our problems. All right, so this project, I'm investigating basically how we can transition from IPv4 to IPv6. All right, I'm experimenting with different hardwares, different softwares, and documenting all this on our log, our log ticket tracker, as well as other documentations. And now we're gonna go ahead and talk more about it. So before I go any further, what is IPv4? Does anyone here know what IPv5 is? Or did you know that it even exists at one point? Yeah, IPv5 did exist. It's actually an experimental protocol. And it just never became anything. And so the successor for IPv4 became IPv6. All right, a little bit about IPv6 is that it is the replacement internet protocol for IPv4. All right, it was created to look into the corrected deficiencies of IPv4, make it easier for addresses as well as allocate more addresses. So, for example, IPv6 has 128 bits. All right, and so if you do 2 to the 128th, you get 340 trillion addresses, also known as undecillion. All right, versus IPv4, 32-bit. All right, maximum that can handle is 4.3 billion unique IP addresses. And so, back in the day, they had a plan to implement IPv6 address. But the problem was someone created NAT, Network Address Translation, which created private IP addresses. And because of that, they've been still using the old IPv4, using NAT for current technology. But obviously, that's not going to last forever. And so now it's important to look into IPv6. All right, for my project, again, Windows 7. So a little bit about VIATA and BIOS, because a lot of this I didn't know, is that it's a Linux-based networking operating system. Provides software-based network, routing, firewall, VPN functionality. And so I use my VIATA to make it act as a router. Fedora 19, also open source, just Linux-based operating system. We've already used this in a lot of our class work. All right, one of the first things I had to do is I had to use VirtualBox. All right, primarily though I use the internal networking network setting. Reason being is I want all that traffic to stay within the network. All right, so that way it's only visible to VMs on that same network, and I don't want it to leave. And so when I created the Fedora 19, I had to create 2 Fedora 19 VMs. Using VirtualBox, or on the VirtualBox, named F19A, F19B. Right, there's specific specifications that I had to meet, like 1 gigabyte RAM, 10 gigabyte disk space, and install it on a virtual hard drive. Next, I had to update the Fedora 19 box to the latest patch using Yum Update. Yum stands for YOLO Update Manager, YOLO Update Manager, and so that's something I learned on the job. Next, I changed my network setting to internal network, which I just mentioned. Then I tested my communication between F19A and F19B using regular ping for IPv4. After that was successful, I transitioned to pinging F19A, F19B using ping 6 for IPv6. Something I found interesting, though, about pinging with IPv6 is that there's a thing called zones.scope ID. This is the number that's, as you can see right here, a percentage and a number. What does that mean? And so, to explain it, imagine you are pinging this address right here, the red one, and you have on your current, from your current computer, but your current computer has two network interface cards, these two blue ones. So which one does it exit? How does it know to go to that red one? And so that's what the scope ID is for. It identifies which one to leave out and then ping to. You can think of it as the number for the NIC card. That's one way of understanding it. All right, the next task I had was installing Viata BIOS on using the VirtualBox. In this, though, I did similar settings, but I had to change the root password for security reasons. Again, I choose to use the network setting for internal networking. And then I need to establish communication with Viata via F19A doing IPv4 ping. Once that was successful, I moved on and tested the Viata router IPv6 connection just using a ping 6 on Google to see if there was a connection with IPv6. Once that was successful, I moved on to communicate with Viata and the F19A using ping 6. Finally, once that was successful, I went ahead and created an IPv6 firewall. The IPv6 firewall provides some basic, some sort of protection because you're going to be going out to the internet. And so I got this from my boss. He told me to implement this. This is basically firewall settings and rules. Basically, I took this and I pasted it into this command called VI that you can use. Think of it as a text editor, so you can paste it in there, you can save it, and then once I saved it as a file, I actually used this command called secure copy to merge it onto the Viata file, so that way I could have those settings. But to do that, because it's a secure copy, you need to establish a secure shell for both the operating systems. So once I establish the secure shell, once it's open, I then did the merge copy, and I merged it over. I verified it by using a show firewall to see that all the settings were correct. Once it was correct, I committed, and then I saved it. Very important is, if you don't save it, you have to do it all over again. So, save your work. All right. Afterwards, after I set that up, I started looking into setting up stateless auto configuration known as Slack on Viata. Okay. Then I was tasked to use a filter TCP dump to capture router advertisement traffic. Then was to install Wireshark on Viata. That was a lot of work, but we got it. Then use Wireshark to view RA traffic. Lastly, set up stateless DHCP Dynamic Host Control Protocol version 6 on Viata and BIOS. Just real quick, DHCP version 6 is definitely different from DHCP version 4. Although they have the same architecture, DHCP version 6 uses a different UDP port, and there are other minor things, but yeah, different protocol. All right, for establishing Slack, what I did was I created just a brand new IPv6 address for testing, and I assigned it to Ethernet 0. Once I assigned to Ethernet 0, I did the following commands. So in Viata, to do these commands, you have to go into this what's known as configure mode. Once I went to configure mode, I set the router advertisement settings. What that does is it sends router advertisements on Ethernet 0 every 10 seconds. All right. And then auto configures an address on Slack Viata default. Auto configures the default gateway to point to Viata, and then auto configure non-address information. Once I did all this, I committed, I saved it, and then I started using TCP dump. TCP dump was, for this filter, I had to do a lot of research because, you know, in the past coursework, we did just, you know, filtering for UDP, TCP, but now I'm looking for RA traffic for IPv6, something I had no idea about. And so I found this, this command online through research, basically TCP dump interface Ethernet 0, and this number 134 is actually the number that references the RA traffic. And then I write it to packet capture file. And then in Wireshark, I look just to see if there was some router advertisements. Once I established that, I moved on. For DHCP version 6, actually there's two types that we should know about: stateful and stateless. So stateful basically means that the DHCP client will get its IP address from the DHCP server, and as well as other configuration information. Whereas stateless, the DHCP client auto-configures its own IP address. And then it uses the DHCP server just to get configuration information, such as addresses of DNS servers, and there are other types of services along with it. So the one that I'm focusing on was the stateless DHCP. All right, so another task that I had to do was actually had to do a DHCP version 6 configuration. All right, so basically I followed these step-by-step guides, and I enabled DHCP version 6 server utilizing the configure mode in Vayada. I set the service, DHCP version 6 server. I committed. I showed the service to see that it did in fact work, and then I saved it. Next, I configured DHCP version 6 address pools because I want the system to act as a DHCP server for the network. Then I created static mapping because I wanted to specify a specific IPv6 address to a specific host, rather than having it dynamically assigned. And then I worked on setting up the DHCP version 6 relay, and then finally setting up a DHCP version 6 client. The next thing I want to talk about is tunneling. This is important because this is how you can connect to an IPv6 website. All right. For example, what is tunneling? It's a protocol that enables new network functions while it's still preserving the underlying network as is. What does that really mean? Okay, so it means this. All right, so say you want to provide a secure path for an untrusted network. Or let's say you want to do IPv6 tunneling, which enables IPv6 host and router to connect to another IPv6 host and router on an IPv4 internet. Right. For example, when I did tunneling at my house, this is my IP address, and then they assigned me an IPv6 address. Because I have an IPv6 address, now I'm able to access an IPv6 website. And so by doing that, I just did tunneling because I used the IPv4 network, internet, and then with my IPv6 address, I made it all the way to the website. I looked at it, bam. Tunneling. All right, transition mechanisms. So there are a lot of workarounds for users to use IPv6. These are the fours that I particularly like. There's actually a lot more, but it gets kind of deep. But 6 and 4, also known as 6 and 4 tunneling, it uses tunneling to connect IPv hosts over the IPv4 internet, which was Hurricane Electric, which is what I just talked about, the 6 and 4 example. All right, 6RD, similar to 6 and 4, but the IPv4 and IPv6 network IPv6 addresses comes from the internet service provider, and the tunneling on there stays within that provider's network. But for this to work, you got to have a capable customer premises equipment known as a CPE router. All right, NAT64, network address translation, makes it possible for IPv6 only to host to connect to IPv4 only servers. Again, for this to work though, the provider will map the IPv6 prefix into IPv4, making that connection possible. Finally, dual stack light. All right, this resolves the issue where an ISP needs to connect to customers to both IPv4 and IPv6 internet. For this to work, the customer needs a native IPv6 connection with DS-Lite capable CPE that supports IPv6 tunneling and IPv4, hence the name dual stack. All right, additional projects. This is like my favorite project right here. This is what I love to do. Yeah. So I literally built 18 out of 37 desktop computers using the MSI motherboard, AMD A10 7700K series CPU. up to 3.8 gigahertz. All right, Ripjaw G skills, DDR3, 4 gigabyte times 2 RAM. All right, Western Digital 250 gigabyte hard drive, and I put this all into a small black tower. All right, I saw Mr. Steve Rondo build this one time. I memorized it. That's how good I am. This is the amount of this is the amount of work that Michelle and I have completed so far. Steve and I also helped too. So. All right, so my learning outcomes. In this project, I learned a lot about different operating systems. Windows 7 I already knew, but Fedora 19 and Viata a lot more. I learned how to convert IPv6 into this compact form. I knew a little bit about it, but had to do a little bit more with some practice, as well as converting IPv4 decimal to IPv6 hexadecimal. You don't actually need to do that, but I learned how to do it anyways. All right, I learned 63 new Linux commands. Don't memorize it completely yet, but I know it because I got the guide. Right. IPv6 transition mechanisms, so I studied the 6N4, 6RD, Net64, DNSLite, MAP-E. It goes on, there's a lot. I looked into the IPv6 3 reachability scopes, globally addressable, meaning like you go outside to the real world and communicate. Link local, you can tell this by the FE80, that stays within local. And then no local, similar to the 127.0.0.1 local interface on IPv4. I learned how to configure Slack on Viata, configuring DHCP version 6, configuring tunneling on Hurricane Electric, as well as learn how to build 18 desktop computers. My future plans. I'm going to continue working in VA tunneling through the tunnel worker on Hurricane Electric. A lot of tools and resources on there that I want to still learn. I need to study more on IPv6 security side. Actually, there's a huge security side on it. Like, for example, we're talking about, let's say you're getting router advertisement traffic, and then there's actually a bad guy who's actually sending you router advertisement traffic at the same time. So then, like, how do you defend against that? Well, they have this thing called RA Guard, which defends it. But there's actually more to it though, and I'd like to learn more about that. So again, instead of ARP spoofing, we have ND spoofing, which is neighbor discovery spoofing. First hot protocol vulnerability, denial of service attacks, user authentication authorization, eavesdropping, session hijacking, DNS spoofing. This is like information assurance all over again, right? Routing security, dual stack related exposure, tunneling related exposures. All right. So next I'm going to actually be doing my software updater image deployer position starting on Monday. I'm excited about that one. I've been waiting for this.
Where's that company?
Pardon me?
Where's that company?
That's going to be here with Mr. Steve Rondo.
Oh, okay.
Yeah, I'm just going to continue on, press forward. Then I'm going to work on the IPv6 certification of Hurricane Electric, just to get more knowledge, better understanding, as well as get that cert. I'm already on stage 4 enthusiast, this level right here, enthusiast level. Hopefully I become a god. That's my goal. In conclusion, so previous courseworks, Foundation of Information Networking, Foundation of Information Assurance, hardware and software definitely helped a lot, especially with using TCP dump, networking, the whole IPv6, building the computer, hardware and software. So all of which helped with my primary and secondary project. I gained valuable work experience in this internship. This internship gave me knowledge, skills, and abilities with IPv6. This is actually valuable in my current position right now with, as a network engineer for my company, Special Operations Solutions. So I can bring that back to them and say, guess what, I learned IPv6. So I'm pretty excited about that. Lastly, I learned not only about IPv6 transition mechanisms, but in addition, new Linux commands, new operating systems, and finally, building the desktop computer.
Yes.
That's the best part.
Question?